Hello, everyone, and welcome to another episode of 10 Minutes to a Better Building, the podcast brought to you by Boland. We appreciate you joining us for this episode very much. Today, we are talking water. Now, water is like the lifeblood of a building, and so it's important to talk about. It's important to discuss, and joining me to discuss water today is Ben Feeney. He is the Water Technologies Division Manager at Boland. Ben, welcome. Thanks for joining me.
Thank you, Tyler. Glad to be here.
Absolutely. So, Ben, help us understand the importance of water to a building and why treating water well is so crucial.
Sure. We want to start with the fact that water is advantageous to buildings because it has a high heat capacity. It's also relatively cheap. So because it has one of the highest heat capacities of any liquid, we can really disperse and get rid of heat in a building quite effectively using water. So it's abundant as well. A lot of advantages there. The downside to water is it's full of impurities and minerals that deposits on the equipment. And, we really need to keep that equipment clean to have maximum efficiency and so forth. So water treatment chemicals are certainly important to stop corrosion, bacteria, and scaling. Those are kind of the three legs of the tripod there. And if we're doing those things, we can keep the equipment lasting for quite a long time, including the piping in the building.
Excellent stuff. And we're going to talk in more detail about a lot of the things you mentioned there. But one of the key terms to discuss when discussing water in a building is cycles of concentration. So tell us what that means, what those are, and why they're important.
Sure. Yeah, cycles of concentration is an industry word that us water treaters use quite often. It's getting more buzz in buildings now that more building owners are looking to save on water and find other areas of energy savings. So the way I would describe cycles is if your piping system in a building was empty and you just filled it with water for the first time, those impurities in the city water that came in, that would be one cycle of concentration. Now, at one cycle, the minerals in the water are low. They're not going to really deposit out on the equipment. So that's kind of safe at one cycle. The problem is if you ran at one cycle, you'd be blowing through water like crazy. You'd be taking the water in and then dumping it and then taking water in again. Your water bill would be through the roof. So what we want to do is recirculate that water, especially in a cooling tower system, as often and as long as we can without dumping water. And in water treatment, what we do is we have a controller that senses the minerals in the water. And when you get up to 5 cycles, 3 to 5 cycles, that water treatment controller will say, okay, we need to dump some of that water to get some of the impurities out and make sure that it's not saturated. The problem is when you reach a saturation point with the minerals, they're going to start dropping out of solution. Of course, we have chemicals that help increase your cycles in a building that ties up all those minerals and keeps it in the water. But no matter what kind of chemicals you throw at it, there is a point of no return where you're going to reach a saturation point. Those minerals will drop out. They're going to get on your equipment. It's going to cause fouling, clogging, all kinds of problems. But as water treater, we provide the right chemicals to keep that mineral balance where we want it. Most buildings run roughly 3 to 4 cycles in DC because of the city water is so dirty. It's hard to go much higher than that without, adding some sort of equipment to do that job for you.
So are there ways then to increase your cycles of concentration? Are there methods that someone like you can take to increase that?
Yeah, great question. The easiest thing to do is to install a water softener. Mm-hmm. That'll really bump up those cycles, from 3 to 6 to up to close to 10, if the conditions are right. And, that's a lot of savings that we have to blow down less water down the drain, less makeup water as well. And you can have 40 to 60% savings when you combine your sewer and makeup water savings together. And the main reason for a water softener, what it's going to do is it's going to remove the calcium, from the water. And, most minerals dissolve under warm temperatures. The problem with calcium is it's the opposite. As temperatures are warmer, it's going to drop out of the water. So that's sort of the limiting factor for water treatment, or the first limiting factor is calcium. If we can remove that, then we look at chlorides and other elements in the water, but it allows us to push those cycles up higher.
Good stuff. So, Ben, when a new building is built, what are some things to get correct, from the get-go from a water treatment perspective? What sorts of things should be thought through and implemented from a water perspective once a new building is kind of ready to go?
Yeah, I mean, there's a distinction between a brand new pipe that's just formed from manufacture and a pipe that's had water flowing in it for years. A pipe that's been treated with chemicals, has water going through it for years on years, kind of as a natural protection. It's like a microcrust of corrosion that protects the base layer of metal from corroding further. However, brand new pipe from manufacturer really wants to corrode quickly as soon as water is put in that piping. And with new construction jobs in particular, there's pipe slag, oils, and greases from manufacturer in that pipe. So at startup, really as soon as water is put into the piping system, it's important that a water treater is involved and that they can put in kind of a high pH alkaline chemical to clean out the greases, the pipe slag. A lot of the iron that's going to happen just from the water touching brand new pipe, it will flash rust. We want to get rid of a lot of that iron out of the system. So it's going to require chemicals to be put into those piping systems for 2 to 3 days, let it circulate. We typically tell the contractors then to flush the system, for a good 24, 48 hours and purge it. We'll follow up and check the iron levels, make sure, they're not going up and that they're down to close to zero. At that point, we know that we've, cleaned out the system and we're ready for normal water treatment chemicals for the life of the equipment to protect it from corrosion.
Another thing that often gets discussed in this conversation are closed loop recovery programs. Tell us what those are and what they can achieve for water inside of a building.
Yeah, oftentimes, no matter what, closed loops, and we define those as a loop that's not open to the atmosphere. Water is just circulating nonstop. After a number of years, or if, let's use our previous example, a new construction job was not flushed out properly, right? It could be full of iron, minerals, and, that can really wreak havoc on pump seals, equipment. Hotels have issues with their units clogging up all the time. They're constantly having to purge their AC units to get that water flowing. So what we can do is as a water treater, we'll come in, we'll do an analysis of the water, see how much iron and debris is in there. And it's really a flush and filter kind of method. So again, we'll just go in with an alkaline chemical, maybe a chemical that can get inorganic materials such as calcium, iron, really redissolve those minerals from the internal piping gently without causing corrosion, and flushing and purging the system until, again, iron levels are low enough, close to zero. The dirty water looks cleaner. And at that point, we would install a cartridge filter system to help polish off any remaining minerals and just keep that system clean, for the duration. Once that process is finished, we feel like we filtered everything out pretty good. We're going to increase the pH gently with some chemicals. We're going to buffer it, and we're going to increase the corrosion inhibitor levels, and we're going to maintain those levels. That's key. For the duration, and we'll check them on a monthly basis, and just add chemicals as needed to top it up.
So, Ben, we've obviously covered a lot of ground here in 10 minutes. This is a big topic to try to cover in 10 minutes. We've talked about cycles of concentration, closed loop recovery programs, things along those lines. Anything else you want people to know before we wrap up this episode here discussing water?
Yeah, sure. We've had some issues with aluminum corrosion recently, and obviously aluminum it's got a higher. It can allow more current through it, more efficient. It's also a little bit less costly. Aluminum boilers are being implemented. A lot of aluminum glycol systems. And what we're noticing, especially for glycol systems that have aluminum components, the right type of glycol is not being ordered. Glycol has a high pH, but aluminum needs a pH between 7 and 8.5. So, especially for mechanical contractors and those who are speccing out jobs, it's really important to order the proper glycol and, to ask for that glycol pH to be buffered down to 7 and 8.5. A lot of aluminum systems are corroding because the improper glycol is being added. So I just want to make that note. I think that's important as we're more materials of construction are going towards that aluminum side.
Ben Feeney, Water Technologies Division Manager at Boland. Ben, thanks so much for joining us today and talking a little bit more about water.
Hey, it's a pleasure. Thank you, Tyler.
Absolutely. Pleasure is all ours. And thank you again so much to the audience for joining us here today on this episode of 10 Minutes to a Better Building. We appreciate it very much. Of course, for more, you can always subscribe to the podcast on Apple Podcasts or Spotify, where we have a number of other episodes you can go back and check out on a lot of different topics. And so if there's something regarding your building you want to know, there's a chance we've recorded a podcast about it. So go check that out there as well. You can also find more on Boland.com. So make sure to do that. But for Ben Feeney, I'm Tyler Kern. We'll talk to you again soon.